So the next type of factoring that we're going to review, or it might be brand new, depending on if you guys had time to get to it, is sum and difference of cubes. So we did difference of squares, which is like maybe x squared minus 49, or x squared minus 36, or x squared minus 9. Those are like really basic examples. This is sum and difference of cubes. So looking at those perfect cube numbers. So before we go more deeply into this, we're going to write down what some of those perfect cube numbers are so that we can recognize them. So I'm just going to write them off to the side. We've got 1 to the third is 1. 2 to the third is, anybody know? 8. 3 to the third is 27. 4 to the third is 64. 5 to the third is 125. 6 to the third you can use a calculator. It's 200 something. 260. Not 60. 16. 7 to the third. $343. And 8 to the third, we probably won't get that high. 512? Okay. So typically they stay somewhere around here because cubed numbers get big really fast. So they don't typically get much bigger than this. And these ones are a little bit harder to recognize than perfect squares because perfect squares you've typically worked with quite a bit. Cubes, not so much. So these are the numbers we're going to recognize in sum or difference of cube problems when we have to factor them. So I'm going to tell you guys what the formulas are, but we're not really going to memorize the formula. We're going to memorize the pattern, if that makes sense. So we have something cubed plus another thing cubed. And when that is factored, it would be the first thing plus the second thing. And then the first term squared minus the first term times the second term plus the second term squared. Oops, sorry, there you go. So that's sum of cubes. Difference of cubes is very similar. So it's the first term minus the second term, and then the first term squared plus the first term times the second term plus the second term squared. So they're very similar. So there are two ways that I remember how to do this. First of all, did you guys learn this in Math 3? Not familiar? Okay. So the way that I remember this is the first sign matches with the sign of the problem. Okay, so it's the same sign. The second sign is the opposite of the sign of the problem. And then the last sign is always positive. So to remember my signs, I think of SOAP. Same sign, opposite sign, always positive. Okay? So SOAP helps me get my signs. Next, I take my color. So let's start with the first color. So my first term is going to be something to the third power. And what you'll notice is that we've got the first term is used. And then if the first term is squared, we have the first term times itself. So it's used once here, but it's used twice here. And then we have the first term times something else. Okay? So this is used in the first half of the parentheses. It's used in the first half of the parentheses. Okay? Bear with me because it's a pattern. Next, I'm going to switch colors. Now I've got the second term. So now I've got the other half of this parenthesis. And then I've got the other half right here. And then I've got this term times itself. So if you can kind of remember the pattern, you don't have to memorize the formula because you can just do the pattern. So we have SOAP is going to help us with the signs, and we have the colors are going to help us with how many times to write each term. So we have a little parenthesis and a big parenthesis, and it goes 1 of the first term, 1 of the second term, and then 2, 2, 2. And it's half of one color, half of another color. So if you kind of memorize the way that it should look, then you don't have to memorize the formula. Okay? So we're going to practice that a few times until it makes sense, until it sticks. Okay? So let's go back to our colors. We're going to do this for the second formula as well. So we've got the first term, and we've got the second term. And for the first term, we've got once for the little set of parentheses. And then we're going to use the first color for half of the second set of parentheses, and we know that each term is used twice. So we're going to have A times A times something. So there's half of all the terms. And then we're going to switch colors. We've got B. And we've got B, and we've got B times B. So at this point, we just need to have actual numbers in here. We got to practice our pattern, okay? So let's try this with a simple problem. So we're going to factor x to the third minus 216. So when I start a problem, I'm going to look, I'm going to make sure that I've got sum or difference of cubes. I might make sure that it's not difference of squares because that is something that we do know how to factor. So I look at this, 216 is a perfect cube. So I'm going to rewrite this problem as x to the third minus 216 is 6 to the third. So x to the third minus 6 to the third. And then I know that since this is the difference of cubes, now I know what my signs should be. So I'm going to start off by drawing my little set of parentheses and my big set of parentheses, and I'm going to put my signs. I'm going to put the same sign and the opposite sign and the always positive sign. And I'm going to start with the first color. So in the little set of parentheses, it goes once. And then in the big set of parentheses, we're going to have 2 things, 2 things, 2 things. 2, 2, 2. And each color goes for half of the parentheses. So I'm going to have 2, and then 2. But I can only do half of the parentheses in this color. So I only get to write it once before I have to switch colors. Does that make sense? Okay. So now I'm going to switch to my other color. Okay, so now I do my little set of parentheses, I get 1, and now I'm going to finish with the 2, 2. After this, I've done the pattern out, so now I can simplify and make it look correct, make it look like math. So my first set of parentheses was just x minus 6. My second set of parentheses was x times x plus x times 6 plus 6 times 6. Now, this part here, if I could factor the regular trinomial and say what multiplies to 36 but adds to 6, if that was factorable, I would factor it, but it almost never is. So typically we are done factoring at this point and we can leave it. If you said, Miss Rice, can you give us an example where it is factorable? I cannot give you an example because that's how rare it is. It is very hard to find one that actually factors. Okay, so typically you're just going to be done when you get to this point. All right, how are your brains doing? Feeling okay? Okay, let's try another one. I'm going to use numbers that are just a little bit more. Do you guys want numbers that are a little bit more difficult, or do you want to do another simple one? A little bit more difficult. Give us a challenge. Okay, so we're going to try 512 x to the third plus 27. Okay, so for the first term, we have to rewrite it as something to the third. And then for the second term, we have to rewrite it as something to the third. So 3 to the third is the second term. 8 what? 8x to the third is the first term. Okay. So we're going to have our little set of parentheses and our big set of parentheses. And what should the signs be? Plus, so same sign, minus for opposite sign, plus for always positive. Okay, we start with our first color. And what do we do with the first color? In the little set of parentheses, what do we do? Put it in the first spot. And then what do we do in the second set of parentheses? Half of the parentheses, half of the parentheses. So how many times do we put it here? Twice. So 8x times 8x. How many times do we put it here? Once. Okay. Switch colors. All right. And then what do we put here? 3. What do we put here? 3. And then what do we put here? 3 times 3. Okay. So let's go ahead and clean it up. We got 8x times 3, or 8x plus 3. And then what's our next parenthesis? 64x squared What else? Minus, what would this be? 24x plus 9. Perfect. Okay, how do you guys feel about that? Good? Should we do one more example, or are you set? Good? Good? Okay. We have one more type of factoring that is going to be, should be new to everyone, and this is called factoring by grouping. Factoring by grouping. And this would be a little bit easier probably than what we just did. Your brain will probably adapt to it a little bit better. So factoring by grouping is pretty easy to recognize because you're going to factor by grouping when you see 4 terms. So here's our example. We're going to do 8y to the third minus 7y squared minus 64y plus 56. So when you factor by grouping, you do what it says. You group 2 terms together, and so if it's written in order like this, where you have your degree in descending order, where you have your highest exponent first, and then your next highest exponent, and then your next highest, and so forth, you typically split the polynomial in half. So we're just grouping it into smaller chunks. And then what we do is we look for the GCF between the first 2 pieces, and we look for the GCF between the second 2 pieces. And what should happen is when you take the GCF out, the leftover pieces should be the same. That's what happens. And if that doesn't happen, then you can't factor it by grouping. So if you look at 8y to the third minus 7y squared, what is the GCF? It's not a number. Y squared. Yeah, that's what's in common between the 2 pieces. So I would take a y squared out, and then when I take a y squared out, what is left over? 8y minus 7. Okay? And then over here, we've got a 64 and a 56. What number divides into both of those? An 8, okay? And now we know our hint is that our parentheses should be the same. The other thing is it's proper, I don't know if you guys knew this, but it's proper that anytime you have a negative in the front that you should take a negative out with the GCF. So if we've got a negative here, we should always take the negative out with that. So we're going to say -8 is the GCF. Do we have a variable with our GCF, or should it only be a number? Just a number. Okay. So if we take, it's negative because the 64 was negative, and if you have a negative in the front, it is proper to take it out. Yeah. The other hint that you have is that you want 8y minus 7 to be what's left over in the parentheses, because that's how grouping works. If your parentheses are not the same, you wouldn't be able to do the problem. So that's kind of a hint, is that we have a negative 64 here, and we want to be able to have a positive 8y there. That's our goal. Yeah. So if we did negative 64y divided by -8, what do we get? 8y, yeah. And that's a good sign because we want this to be the same. And then if we do a positive 56 divided by -8, we do get -7, which is what we wanted. So you want your parentheses to be the same. So the next step is actually to take out the GCF again. And this is the part that feels a little weird because your GCF is actually going to be the parentheses. So what you're going to do is you're going to say this is one term, this is the second term. So we've got one term, we've got the second term, and between these two terms, this whole thing and this whole thing are in common. Do you guys see that? We've got the first term, we've got the second term, we've got this whole thing is in common. So this is the GCF. I'm going to take the whole GCF out. So 8y minus 7 is the whole GCF. And then because we had two terms, that means we're going to have two leftovers in our next set of parentheses. So what should the two leftovers be? Y squared and a negative 8. So y squared is the first leftover, negative 8 is the second leftover. So that's probably the weirdest part of factor by grouping and the part that messes with students the most. Okay, how do you guys feel about that part? A little weird? So how do you recognize that a problem is a factor by grouping problem? 4 terms. That's your biggest way. So factor by grouping is when you get into higher levels of math, it starts to be more common. And this is the specific part that you start to see that's more common, is where you have sets of parentheses that are GCFs that you can start to pull out. You'll be like, oh, it's not a GCF of like a single number or a GCF of a single variable. It's actually a GCF of parentheses. So they'll start factoring by grouping, and that's kind of what they'll start to take out. So the reason we're going over this is because if you continue in your honors math past this class, if you decide to go into pre-calc or maybe you want to try to get into calculus or something like that, this type of factoring becomes more common. All right? Okay, so the rest of the period we're going to practice some more factoring. The assignment after this is pretty long, and what I'll probably do is make a bunch of it extra credit and make part of it regular credit, and I don't know which is which yet, so I don't want you to be intimidated when you see the length of the assignment. We'll work on it, and then we'll make a decision about how much we should do. Does that sound reasonable? Okay. So for the assignment that you guys have